Hello guys, welcome to Deep Neural. Vijay from this side. This is my first video and this is my first channel on the YouTube. This channel is fully dedicated for learning, understanding technical plus theoretical concepts behind data science and machine learning related concepts. So majorly I will cover the theoretical concepts plus technical terms and we'll do some coding as well. Right now I started a mission where I will be covering 6 months, next 6 months for upskilling myself without wasting single day. So that's my that is my path to follow. I should follow for the next 6 months. And during this period, whatever I learned about machine learning, I already learning this machine learning and mathematical concepts. But now I realized that consistency is the key. If you are not consistent, then I honestly I forgot a lot of things whatever I learned before. So that's why I'm going to start this journey. If you want to join me with this journey, it's very fantastic. So without wasting much time, let's dive into the technical terms for the today's video. So this video will cover two topics, that is what is machine learning and what are the types of machine learning. So my motive is that to cover whole syllabus from what is machine learning to training a foundational model on different machine learning algorithms, right? So that is what I'm looking for. So let's get started. Okay. So let's understand first. First topic is what is, okay, my handwriting is very bad. Uh, what is machine learning? So here I will give you a real life example to correlate this machine learning with the real world. Machine learning is similar to student and teacher relationship, student teacher plus blackboard relationship. What it means, so let me explain you first. Let's say this is the blackboard. Okay. This is the blackboard. uh, Here is the teacher and a student. Here is a student. Okay, something like this. Okay. Teacher, student, and blackboard. This is the thing, but the machine learning concept. What you understood from this? Okay, let me explain you first. Here, teacher is teaching something by referring this blackboard to the student. Now, student don't have any knowledge or understanding about that concept, and the teacher is teaching that same concept by referring this blackboard. So you can say that blackboard is like a data, teacher is a machine learning engineer, and student is our blank model. What is the meaning of blank model? Blank model means untrained model. Okay, so parallelly I will draw uh, the diagram which is the correlation about machine learning and real life student and teacher relationship. So here blackboard refers to data. This is data data. It's a CSV file maybe or Excel file, don't matter. The machine learning engineer, ML engineer. And here is model. So here ML engineer will give some data to this model. This model will observe this data and it will create some pattern, some equations, and it will get trained for the future problems, right? So this is nothing but the machine learning. That's very simple. This is it's very much related to real life things, how we learn, how human learns. It's very simple. So now I think it's fine. Let's move towards the next topic. So majorly there are four types in machine learning. Let me draw first hierarchy. Machine learning. So first type is supervised learning. Supervised learning. Second one is unsupervised learning. Third one is semi-supervised. Supervised learning. And fourth one is reinforcement learning. Now let's see one by one what is supervised, unsupervised, semi-supervised, and reinforcement learning. So let's take first, that is supervised learning. Okay, so supervised learning, the name itself tells something about that. Like supervised learning refers to a data which is under supervision. What is the meaning of that? The data which has input columns and the output columns as well. So this kind of data, when you train model by using this kind of data, then it's called supervised learning method. Unsupervised learning is opposite to that. I will tell you after that after this session. Oh. So let's understand first what is supervised learning. Supervised learning, name itself tells something about that. Supervised learning is nothing but the learning which happened under supervision. What is the meaning of that? Let me explain you. The supervision part is done by the output column in the data. Let's say you have this data. There are let's take one example of fruit classification. You have features of features of fruit, fruits, fruits, and your work is to predict which fruit belongs to these features, which fruit belongs to these input features. Okay. So in this data, features may contain the weight of fruit, then color, then taste, and then taste, etc. So these features are the input features. Okay, and the output column will contain which fruit belongs to these features. Let's say there is a fruit which has 20 grams of weight, then color is green, taste is sweet, then it belongs to grapes, right? Take the next example. If weight has 1000 grams, weight is 1000 grams, then it's a green and sweet. It is watermelon. Okay, so these kind of data, this is the data, this is supervised data, which is the input columns are under supervision of output columns. So these are the input columns and this is output column. So the main or the major part why it is called supervised is input columns are under supervision of output column, under supervision of output column. So this is called supervised learning. So model will understand which kind of features belongs to which output, right? This is the task of supervised learning. Now let's understand unsupervised learning. Unsupervised learning. Now you may understand what is unsupervised learning very easily. The major difference is that in this learning, the data does not contain output column. Only input columns are there. Only features are there. Let's take the similar example of the fruits classification. Here, the data or CSV will contain only features, only uh, input features. Okay, so these input features or these input data points are given to model, and model will create a different groups of this data. Let's say you mixed three fruits data, not three fruits. You have data around 1000 columns maybe. It's not necessary always 1000 columns should be there, but for example let's understand, let's take one example, that is you have input data with 1000 columns, 1000 rows, sorry, my mistake, 1000 rows are there, 1000 rows is 1000, one, okay, and you have input features similar that we already observe here. So weight, color, test, right? So input features, weight, color, and test. So in unsupervised learning, what model will do, it will it will classify, it will create clusters or groups of similar data points. So that means it will, let's say ki, we have three fruits data, three fruits data. So this input data or CSV file will contain three fruits of data only. So this model will create three different groups: first group, second group, and third group. And the classification or clustering is based on similarity in input features, or separate out the data by understanding the similarities in the data points. So this is the basic concept behind unsupervised learning. So now let's see the next topic, that is semi-supervised learning. Supervised learning. So now semi-supervised learning, why we need semi-supervised learning? Let's understand that. Let's say you have 1000 data points with label on it, and 2000 data points without labels. Now your task is to create a solid or a more accurate model based on this data. So now your data is mixed with supervised data and unsupervised data, right? So you can't even go for one solution. You can't go for the only supervised learning method or only unsupervised learning method. You need to combine them together and build a single model to solve this problem, right? So for this we are using semi supervised learning. So majorly there are different types in semi-supervised learning. I think this video is too short to explain semi-supervised learning methods. So I will just tell you only basic or only single method from semi-supervised learning, that is self-learning. Let me draw here hierarchy first. There are self-learning. There is another type, that is consistency, regularization. Then graph-based learning. Okay, so let me give you a simple example how semi-supervised learning works. So you have input data, input data, right? So this input data contains features and label in the sense output. It's a similar to the output. So if suppose you have 1 to 2000 data points with label data, there are some labels are present, but after 2000 to, let's say, 4000 data points without label, they have features, they are they have features, but they don't have these labels. So this is kind of unorganized data, right? Some of your data points has label, but some of your data point without label. So you don't go for only one solution, either supervised or unsupervised. You don't go for this. So instead you will create a semi supervised learning model. Semi supervised learning model. You will feed that data, feed both the data point datas. Okay, so this is the unlabeled data. This is labeled data. Okay, so now you will get the output output in the sense it's a trained model. You are getting trained model. So how machine learning engineer did this? Even though you have 2000 data points without label, you trained a model that is very fantastic. Okay, let's understand how this model is going to create. How will you create this model? Okay, so semi supervised learning, it will what it will do, train it will train. So by the way, I'm talking about only self learning method, so don't correlate this with other two methods. I will explain them in the next video. So yeah, I will write here, this is the self learning, this is self learning method. So first we will train supervised model by using label data. Train supervised model using labeled data. And next you will use the same model, model for prediction of rest of the data. rest of the data or unlabeled data. The third step is now you will after prediction you will get a label for these unlabeled data, right? And then you are going to train our model on whole data. Train the model on overall data. So this is called self-learning. By the way, this is very simple. You are just training a supervised model, then using the same model to predict for these 4,000 unlabeled data points. And then once you got the predicted labels for unlabeled data, you will train your model on whole data. And this is called self-learning. Understood? This is only one topic from supervised learning. Again, I'm talking. Consistency regularization is the different topic. Graph-based learning is also, it's very exciting thing. I will explain that in upcoming videos. So now you understood what is the concept, right? So whatever we covered, that is supervised, unsupervised, semi-supervised. These three methods are kind of similar. They are taking data, generating equations, and giving you output, right? The major difference is in unsupervised and supervised is that unsupervised learning requires only unlabeled data, and it will create clusters, like clusters. And supervised learning model will get trained on features plus output data, which is the labeled data, and this model can predict the output for the future values or new values. And semi-supervised learning has mixture of supervised sorry supervised or labeled or unlabeled data points, and it will train first supervised model, then it will use the same model for prediction of unlabeled data, and then once it get whole data points with labels, then finally you will create a supervised model based on labeled data. And this is the self learning method from semi supervised learning. Okay, now let's see reinforcement learning. This is very exciting thing. I love reinforcement learning. The fourth one, reinforcement learning. Reinforcement learning. So before diving into the technical part, okay, let's understand this concept with one scenario, a real life example. Not a real life example, but you can correlate that very easily with reinforcement learning. So reinforcement learning is reward based learning. Basically, you will create an agent by giving it some rules, and this agent has some goals to do. So by using these rules, you will the agent will move randomly in the environment, and it will do some random task. Based on this random task, you will penalize that agent if that agent did some mistakes, and you will give some rewards if the agent did something as expected. So the work of agent is to collect positive points and avoid negative points. So due to this, agent will start doing the expected things instead of random or unexpected things, right? So you are this is like rules which are guiding somebody to do some task. This is called a reinforcement learning. And where now let's see what is the use of reinforcement. Already we discussed three topics: supervised, unsupervised, and semi-supervised. These three methods are broadly used, and you might think that these are enough methods because even your data point does not contain labels. These kind of data is getting handled by unsupervised learning. So you may be thinking, what is the point of developing reinforcement learning? Let me tell you that with one basic scenario. It's very interesting, by the way. Okay, so let's say there is a XYZ company. They created a robot with single leg. It's a single leg robot. Okay, my drawing is not that much good. Okay, let's say, okay. So now see, single leg. Let's consider that single leg robot is never created before. It's a fresh new concept in entire world. This is fresh new robot robotic concept with single leg. Now, if these kind of robots are never created before, that means the data is not available. To train these robot, you don't have data, right? So now you can't use supervised learning and unsupervised learning as. So that's why reinforcement learning is there. So let me tell you how they will develop this reinforcement learning model based on some rules. So let's say the agenda of robot is walk. The robot is created to walk by using its single leg. So to achieve this XYZ company will create some rules. XYZ will XYZ XYZ will create some rules to make it work, to make this robot walkable. Okay, so be what what may be these rules? For As per my understanding, there should be one rule that if there should be some rules, one, two, three. It may be it depends on how much rules that they want. So roughly we will I will write some major or some needy rules to make this robot work. The first rule is head should be at higher position compared to other body, compared to rest of the body parts. So this is the rule number one. The second rule will be jump forward, and if it is if it gets jump forward, it will get plus 1 point. And for the first rule, head should be at higher position compared to rest of the body. It will get some positive values depending depending on head position, right? So now if suppose there is another rule that if robot jumped towards left, then right, or at backward, it will get penalized by minus 1 point. So now robot will follow only positive reward based actions. Initially it will fail for lots of time. It may fail for first 1,000 iterations or first 1,000 trials. After that the model will get experience, and model will get some experience, and by using previous experience, previous penalties and rewards, this robot will get to, it will understand what to do and what should not be do. So this is called reinforcement learning. And yeah, that is actually, this is very big topic that is not, I can't cover that in a single video. It requires uh, most a lot of videos sequentially, but it's very interesting because just imagine you have some models, you are just assigning the rules and you are just leaving that model or robot in the environment just learn by yourself. It's very exciting thing, right? And whenever, for each task, for each move, model or that robot is learning something new by itself. So you can imagine how strong this technique is. This is like a self study, right? So you may learn somewhere that is learn through your mistakes. This quote is very nice and it's best fit for this reinforcement learning. Learn by your mistakes. So these are the topics of machine learning. And so let's summarize what we discussed. We discussed what is machine learning. We created one scenario of student teacher relationship, and here I referred blackboard with the data. Then ML engineer is the teacher who is teaching to the model. Model is our student. Student or a model, initially they are untrained model. When the ML engineer gives some data to this model will get trained, and then this model will be ready for future inputs to predict some outputs. Okay, so then we discussed machine learning, types of machine learning. Sorry, I forgot to write there. Types of machine learning. Basically, there are four types: supervised, unsupervised, semi-supervised learning is the technique where we have labeled plus unlabeled data. In unsupervised, we're just using input data, that is unlabeled data. In semi-supervised, we have combination of supervised data and unsupervised data. And we are preferring first, we just saw how self-learning works in semi-supervised learning. Self-learning works by creating supervised model by referring labeled data from the input, and then it will predict for the unlabeled data, and finally we will train the final supervised model based on whole data, that is labeled data plus unlabeled data with predicted values. Then we saw reinforcement learning with one robot and XYZ company, right? Mostly reinforcement learning is a reward based learning where reward will excite model to do that particular thing, and penalization or penalty will reduce the excitement from the model to uh, to do that unexpected behavior. So basically we are creating some rules for the model, and we just left that model in the environment. Model will train by itself by uh, the model will gets trained by his own mistake. That is called reinforcement learning. So that is all about today's video, guys. So let's in the next video I will explain the types of semi-supervised learning model: self-learning, consistency regularization, graph-based learning. So these are the types. I think there are two more types, but I'm not, I don't remember right now. I will cover them, these two uh, two types as well in the future video, in the next upcoming video, sorry. That's all about today's agenda. And this journey was very exciting. I learned a lot of things through this teaching as well. So basically I am creating the environment where I can grow, plus I can learn something, and parallelly I am going to explain these things to you guys, so to understand it very thoroughly. And If you have some doubts, if you have some issues with my teaching method, then please let me know in the comment box. I will try to fine tune my learning method. So sorry, teaching method. So that's all about the today's session, guys. Thank you so much for the joining. That's goodbye.